Okay, welcome to my programming in ARM assembly video series that I'm putting together. Let's jump back into the code. Okay, so in the last video, I set up a bit of ANDing logic to hopefully make sure that the highest possible value that we could get from our random number generator would be no higher than the number that we define when we call the random number function. So actually, let me go ahead and do that now. Let me start that process now. So let's look at main, and let's say before we call rand, we will pass into rand our constrained limits. So and we'll define those. We'll say move into R0 min rand, which we haven't set up an equality for yet, so we'll do that next. And then we'll say move into R1 max rand. Okay, so let's set that up. We'll do that down here because it's kind of a different type of thing. So min rand is, in our case, it's going to be 1, and max rand is going to be 100 for now. We'll play around with those values, of course. And I'll clean some of this up later. So now let's go into random.s. And we were previously temporarily hard coding those, but we're not going to hard code those anymore. So now when we call into this function, R0 must contain. So when this function is called, R0 must contain min rand. When this function is called, actually, let me do it like this. Oops. Min rand. R1 must contain max rand. There we go. So when this function is called, R0 must contain min rand, R1 must contain max rand. And there won't be any there won't be any defined defaults, at least not yet. Maybe we'll define some defaults later. Okay, so now when we call into this function, R0 and R1 contain the min number and the max number, and since we're going to be overriding 0 and 1 several times here, the first thing we do is we make a backup of min rand and max rand so that when we get down here to this point, we have our random number from /dev/urandom. We then use at the moment we're only using the max rand, but we use max rand to make to constrain it. Okay, so let's write that out. Let's quit. Let's go just do a quick remake, and let's just do a quick test. So again, it should be guaranteed that the number cannot be any higher than 127. So that's too high, and 0 is too low. I just want to make sure that that part's working. And actually, let's test that theory by changing max rand to 1,000. So if max rand is 1,000, then the highest, maybe I shouldn't use 1,000. So let me just make some comments here. So 1, say 0, 0, 0, 0, 1, 1, 1, 1 is 15. And that means that, like, this is 255. I should add in some more numbers here. So then if we go here, let's say all these are 1s. What's that number? I actually don't know. I do know that this number is 65,535. Okay, so let's say that our maximum number is just give me a second to think about this. Let's say our maximum number is 20. So that would mean that when we do our bit shift, and let's say 20 in binary looks like this. So it's going to be 16 plus 4 is 20. So that means that when we do our mask is going to look like this. And that number is all those combined. So it's 16 plus 8, which is 24, plus 4, which is 28, plus 2, 30. So that's 31. So if we say that our maximum rand is 31, our current bit max rand is 20, our current bit mask will guarantee that the number is 31 or lower. So let's test that theory. So main 32 is too high, and 0 should be too low. So the number should be guaranteed to be between 0 and actually 31 should be potentially the highest. So it should be guaranteed to be between 0 and 31. So let's say, and at this point I don't care what the actual number is. I just want to prove that it can't be any higher than 31 and it can't be any lower than 0. And that seems to be true. It could potentially be 31. Okay, and let's try that again with another number. So let's try, let me see what this bit mask would be. So that would be 31 plus 32, which is 63. So let's say our maximum value is 50. So that puts us in this range here, which means that the maximum highest number could be 63. Okay, let's remake, clear main. So it should not be any higher than 63. And then, so 60, 50. So in this case, that's another thing I should check to make sure it potentially gets up to that high. So now it's greater than 50, lower than 60, and again, I don't actually care to figure out what it is. So again, 63 is the upper limit. In this case, it's somewhere. Now I do want to make sure I'm not just constantly generating the same number. So let's actually figure out what it is in this case, and then test that a few times. Okay, let's make sure we're not just constantly generating the same number. Okay, we're not. Okay, whatever the number is. So 50 is too low. Let's try 54 again, still too low. Okay, that's too high. All right, so it seems like that's working. Hopefully, I know that's a bit strange there what I'm doing, but hopefully it's easy to understand. Or at least, if not easy to understand, at least possible to understand. And let's do this one more time. Let's move the bit mask over again by 1, which means that our value is now 63 plus 120. No, now it's now 63 plus 64. 60 plus 60 is 120, so it's 127. So now we're saying if our number is, let's say the upper range can be up to 100 and up to 100. So now this should be the bit mask that we're calculating. Should be should be all zeros up to here and then 1 1 1 1 across. So it's possible the number could be over 100, but it will be less than 127. So 127, too high, 100, too low. So yeah, it could still be over 100, but less than 127. So the bit mask is working. That's mainly what I wanted to check. And let me just look at this in the debugger for a second. Breakpoint 1, run, and then step into... Do I even need to step into... Actually, I think I just want to... Yeah, let me just step into for a second, so we can see how this bit mask is working. Okay, so we set register 6 to 0. And then we set R5 equal to R4, so R5 should become 64, which is 100 in decimal. Okay, so we got our backup copy of R5, or rather, we got our backup copy of R4. Now we're going to compare R5 to 0, which of course it's not. So we're not going to exit the loop. We're going to shift right, which is going to reduce R5 by a power of 2. And that's what it did. And then when we do that, we're going to increase R6. We're going to shift it left by 1, which at the moment isn't going to do anything. But then we're going to add 1 to R6, which we've done there. And then we're going to loop, and we're going to do this again. We're going to reduce by another power. Going to shift that to the left, which we've done. Then we're going to add 1, which is going to make that 3. Then 6, and then it's going to become 7. And then 8, but it's going to become... actually not 8. It's going to become 15, or 14 rather. And now it's going to become 15 or F. Yeah. So that seems to be working correctly. So let me see what the value is. Okay, so now R5 is 0, and the final value of R6 is 7F. So let's look at that in a converter. Hexadecimal. 7F is 127, right? And then so that's our bit mask. So yeah, it's doing what I want it to do. All right, continue through to the end, quit, and let's look at random.s. Okay, so now that we have guaranteed our random number will be constrained to no higher than whatever the next bit up would be. So in the case of 100, it's not going to be any higher than 127. So now we need to just compare whatever final number we did get against our bit mask. Not against our bit mask, but against our max rand. And then we need to subtract off. I think if we just subtract off max rand at that point, it won't go negative. Yeah, because if it's already... So let's say that the random number we generate is 80. When we do this next operation that I'm going to set up, it will just automatically go to the exit because it's already less than max rand. But if the number that we generated is, say, 113, then what I want to say is, well, since the random number is currently over max rand, we'll just subtract max rand from that number, so 113 minus 100, and then our number will be 13. Okay, so we've exited the loop, we've ANDed these together, so now we just want to do a final final max rand check. So I'm saying we'll compare R0 with max rand. We made a backup copy of it, and so max rand is actually R4, and branch, hang on, let me think. Yeah, if it's less than that, branch if less than to the exit. So if the number is already lower than max rand, branch to the exit. If it's not, let me say actually less than or equal to. If it's less than or equal to max rand, so if it's 99 or 100, we're fine with that. If it's anything other than that, it means it's greater than. So we will subtract from R0, we will subtract the value of max rand, and that guarantees that the number will be lower than max rand. And I think at that point we're done, because I think the way I'm doing the bit mask, I don't think we have to compare. I don't think that it's not possible for the number to be negative. It's not. I guess the number could potentially be 0 though, so we do need to check for that. But let's try this. Let's remake our code. And now the number should be, there should be no possibility that it's over whatever maximum number we set, which I forgot, 100. I couldn't remember if I set it back to 100 or not. So let's run our program, and now it should be guaranteed to be between 0 and 100. So we want to make a final check to make sure it's not 0, because we've defined it to be 1 to 100. So let's just play the game. 50 is too low, 75 is too high, 62 I believe is the halfway point, too low. Then we want to go to say 68, too low, and then we want to go to say 73 or something, 72 maybe, too high. Okay, so the point is it's certainly constrained between 0 and 100. So let's play it a couple times just to check. So let's just actually go there. That's too high. That's too high. That's too low. That's too low. So it's guaranteed, or at least currently it seems to be in that limit. Oh, that was lucky. And yeah, let me check actually, make sure we're not constantly generating the same number. Oh, 10 is too high. Okay, so it's a very low number this time. Okay. Make sure it's not 0, maybe 100. So we're within, yep. So I think we're generating at least a pseudo random number, and it's constrained. So that was the primary goal that we wanted to do here. All right, so we are really closing in toward the end of this whole thing here. There's just a little bit more that I think I need to do before we call it a wrap. I think it's possible still for the number to be 0. So I just want to make sure that we're checking for that as well. All right, thanks for watching everybody, and I hope to see you in the next video.